Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 3.2.4. Our M&Ms are now officially getting in your notes. What happens when you multiply integers together? What is the meaning of multiplication as far as integers are concerned? And we know that multiplication is repeated addition. So 4 times 3 is literally 3 plus 3 plus 3 plus 3. So you get 12 for an answer. So if you're dealing with multiplying a positive times a negative, we just think of it in the same way. 4 times negative 3 would be negative 3 plus negative 3 plus negative 3 plus negative 3. And if we drew the model for that, 4 groups of 3 negatives would give you a total of 12 negatives. So 4 times negative 3 is equal to negative 12. When we are working through this process where it is negative 4 times positive 3, you can show that as repeated subtraction, but honestly, I would just use commutative property and rearrange those. 3 times negative 4 would be negative 4 plus negative 4 plus negative 4, so you're still going to get an answer of negative 12. So essentially what we learn is this: when you are multiplying two numbers with different signs, you always get a negative answer, no matter what. And we know from all the way back in second grade, when we first started exploring the idea of multiplication as repeated addition, you multiply two positive numbers together, you get a positive answer, because back then we didn't know there were such a thing as negative numbers. Well, now let's extend this. This idea of negative 4 times negative 3 being repeated subtraction of a negative number is kind of complicated to think about. So I like to think of it as this way. If we know that 4 times negative 3 gave us an answer of negative 12, then the opposite of 4 times negative 3 must be the opposite of negative 12, which is positive 12. So eventually, we just remember the basic rule. When you're multiplying two numbers that have the same sign, you are always going to get a positive answer. When you're multiplying two numbers with different signs, you are always going to get a negative answer. Okay? So what do we have down here at the bottom for our example? Negative 2 times 3 is negative 6. Negative 3 times negative 15 is positive 15. And so in the end, when you simplify these two and these two, you end up getting two factors. One of them is a negative and one is a positive, so you get a negative answer. Now, another way of looking at it is this. If you've got a series of numbers being multiplied together, if you've got an even number of negative numbers, right? We got 4 of them. Or if you just had 2, you'd have a negative times a negative gives you a positive, a negative times a negative gives you a positive, so a positive times a positive will give you a positive answer. So if you have an even number of negative signs in your multiplication problem, you're always going to get a positive answer. If you've got an odd number, then you're going to get a negative sign. So a negative times a positive gives you a negative answer, but a negative times a negative gives you a positive. So a negative times a positive, you're always going to end up with an odd number of negative signs, so you're going to get a negative answer. Okay? The more times you do that, the more it'll make sense and it'll eventually stick. All right, so what did we learn today in our lesson? When we are multiplying decimal numbers, remember, decimals have fractional equivalents. So if we were to rewrite each one of these as their equivalent fractions, 2 3/10 is really 23/10. And 5 6/100 is really 506/100. Now we use our rules for multiplying straight across, numerator times numerator, denominator times denominator. And at the end, once we simplify this, 11,638 divided by 1,000 means how many thousands can fit into 11,000? Well, 11 of them, right? So our answer's got to be somewhere between 11 and 12. So the decimal goes here at 11 0.638, or 11 and 638 thousandths. So ultimately, what we end up learning is this. When you multiply decimal numbers together, you're just going to multiply these numbers as if they had no decimal at all. Just like we did here. 23 times 506 gives you an answer of 11,638. And then you count the number of decimal places in the entire problem. You have 3 decimal places, so we're going to put those back into the answer. And so we start where the decimal place would be. If that was 11,638, it would be here. And then we move it the appropriate number of places to the left. Now, here is another thought process I want you to have. It's not going to work for problem B. It doesn't always work. But in this case, it does. Okay? You know when you multiplied 506 times 23, you got 11,638. But that is not the answer, because if I were to round this to 2, right? That's between 2 and 3, but it's closer to 2. And you round that to 5, then 2 times 5 is 10. So your answer can't be anywhere near 11,000. That doesn't even make sense. So this is where estimation comes into play to help you decide where your decimal needs to go. 2.3 times 5.06 has got to be something around 10. So the only logical place for your decimal to go is between the 1 and the 6 and make that 11.638, because if you put it here, your answer would be close to 1, and there's no way that 2 times 5 is 1. And if you put it here, your answer would be 116, and there's no way 2 times 5 is equal to 116 or anything greater than that. The only logical place for it would be here. So your answer has to be 11 and 638 thousandths. This is another way of proving that that's how you get the answer that you get. Now, for problem B, this is a little trickier because I don't know what 4 thousandths times 3 is. I guess our answer would be somewhere relatively close to 0, since that is closer to 0 than it is to 1. And that's between 3 and 4, closer to 3. But still, 0 times anything is 0. So that doesn't really help me decide where my decimal is supposed to go. So we just want to remember the process. You're going to multiply 4 times 342. And you get an 8 there, you get a 16 there, carry the 1, 12, 13. So you're going to get 1,368. And now we have to put back 1, 2, 3, 4, 5 decimal places. But I don't have 5 decimal places, so we'll put in some zeros as placeholders and then count over 1, 2, 3, 4, 5, and that ends up being your answer. Okay, so because the denominator of the fraction answer is 1,000, the decimal answer will have 3 decimal places, right? 3 zeros for 1,000. And because the denominator of this fraction is 100,000, you want this to terminate in the 100,000th place, which means you would need 5 decimal places. So there are a lot of different ways that you can think about it. Whichever way that I explain makes most sense to you, just go with that, okay? I am the type of teacher where I like to teach you a number of different strategies that all work. Some students will like one way, some students will like it another. I want you to use the way that makes most sense to you. And if none of them make sense, then I'll say, okay, just do it this way and memorize it, because we need to move on. But for the most part, most of the time, students embrace a particular strategy that makes sense to them, and then they are successful with their math. So hopefully one of these methods works for you. All right, mentally calculate the products. So here you got 1 times 4 is 4. It's a negative times a negative, gives you a positive answer, and you've got 1, 2, 3 decimal places. So it's got to be 4 thousandths, because that has to be in the 3rd decimal place. Here you've got a positive times a negative, so you're going to get a negative answer, and 2 times 3 is 6, and you've got 1, 2, 3, 4 decimal places, so the 6 has to be in the 4th decimal place. And here you've got a positive times a positive, so you get a positive answer, and 7 times 4 is 28, and you got 2 decimal places, so the 8 has to be in the 2nd decimal place. Now, Stacy said, Stephanie, look at my answer to the last problem. Usually when I multiply, I get a bigger answer than what I started with. 28 hundredths is less than either 4 tenths or 7 tenths. I must have made a mistake. See that stoplight? that's where people make common mistakes. But in this case, it was not a mistake. Because if you think about it, if we go back to multiplying and using the word of, if I take 7/10 times 4/10, what you're basically saying is 7/10 of 4/10. And if I change this to 1, 10/10, if it was 1 times 4/10, you would get 4/10 for an answer, right? If this was a number that was greater than 1, then your answer would be greater than 4/10. But this is a number that's less than 1. So anytime you multiply anything times a number that's less than 1, you're going to get an answer that's less than what you started with. So 7/10 4/10 has to be less than 4/10 because 7/10 is less than 1. So I hope that makes sense to you. So Stephanie is correct. When you multiply two whole numbers, the product is bigger. But when you multiply any number times a fraction, you're going to get an answer that is less than the original number that you had started with. All right, another absolute value kind of a problem. The highest point in the United States is Mount McKinley, which is also referred to as Mount Denali in Alaska. It is 20,335 feet above sea level. So here's the sea level. And let's draw our mountain. And I think this is in Alaska, so it's going to be like rocky with maybe snow all over the place. That's my snow. All right, so that's sea level. And this right here is 20,335 above sea level. Okay. Now, Death Valley is the lowest point in the United States. And I'm going to do this brown because Death Valley is a desert, right? This is deserty. And this point right here is negative 282 feet below sea level. So the distance from here to here is 20,335, and the distance from here to here is 282. So we have to add those numbers together to get the total distance from the lowest point in Death Valley to the highest point of Mount Denali. And so that's where you take 20,335 minus negative 282, which using KFC becomes 20,335 plus 282. So you get a difference of 22,617 feet. Now, why did we have to use absolute value symbols? Because you may have chosen to do it in this direction instead. And that would have given you an answer of negative 22,617 feet, which we don't have negative distances. So that would not make sense. So we're taking the absolute value of this so that our answer is a positive 22,617 feet. Oh, we've got a couple more problems here. What do we have here? All right, so find the mean, range, and median of these values. I don't like finding the mean. Finding the mean means you have to add all those numbers together and then divide by the number of numbers. Finding the median is a little bit easier because with the median, you put them in order from least to greatest. So that's what I've got here. Generally, what I do is I count up the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then as I account for those numbers, I cross them off my list. And I make sure I've got every single one of them accounted for. And what did I say we had? 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now the median is the number that's in the middle. But because we've got two numbers in the middle, we have to take the average of those two numbers. So 2 plus 4 is 6, and 6 divided by 2 is 3. So the median is going to be 3. The mean requires us to add all the numbers together. So if I add all these numbers together, let me go ahead and do some clustering. 8 and 2 makes 10. 9 and 1 makes 10. These two guys are negative 4, which cancels out with positive 4. And that leaves me with 10 plus 10 is 20, 32, 39. So we've got 39 divided by 10. Well, it was a nice denominator for finding the mean. 39 divided by 10 is 3 9/10. Notice how the mean and the median are relatively close to each other. These are both valid averages. Typically, we would use the mean unless there were outliers. And in this case, because the mean and the median are so close to each other, it really doesn't make any difference which one we use. They're both valid. It's somewhere average number here. What is this number set? We don't even know what this refers to, but between 3 and 4 happens to be about the average. And then the range gives you an idea of the spread of the data. How spread out are the data? Sometimes if you have a really big range, that implies that you've got an outlier somewhere. But here the range is 14 units to go from -2 to +12. You can see the work there, right? So, different values for solving different types of problems when you're analyzing data and statistics. And now the last problem, being able to multiply fractions together, just numerator times numerator, denominator times denominator, and then simplify if you can. And it turns out the numerator and denominator have 2 in common, so 10 divided by 2 is 5, 24 divided by 2 is 12. Here, 3 times 2 is 6, 4 times 5 is 20, and the numerator and denominator have a 2 in common, so you divide the top and the bottom by 2, and you get 3/10. And thus concludeth our homework for 3.2.4. Let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk